All right, guys, so we are moving on. If you do not have your salmon colored paper out, you're going to want to get that out because we are going to add to that today. We've focused on solving equations by factoring. We're going to shift gears into the next method of solving because does everything factor? No, not everything does. Granted, I've given you stuff that factors, but not everything does. All right, so this section actually has the next two methods are actually both in this section. We're going to work just today, though, on solving by finding square roots. Honestly, this is one of my favorite methods because it's fast. Should be, okay? Should be fast. All right, so again, make sure you have this paper out. We will fill in the steps for square roots in here just in a little bit, okay? All right, so you can only solve a quadratic equation by finding square roots or using the square root method if there is no bx term in the equation. Interesting. Okay, so that has to be missing, no bx. So which equations are missing the bx term? So there's 4 of them listed. How about the first one? 4x squared plus 3 equals 8. Is that missing the bx term? Yep. So this one you could use the method we're going to use today. X squared equals 9 minus x. No, that right here, your bx term is a negative x on this one. That one cannot. There, right here's your b term. Right there. The plain x. Does this one have a b term? Yeah, it's right here. So I couldn't use this. Could I, this one? That one's good. That's missing the bx. Right, because it's always ax squared plus bx plus c, right? That's our form. So we need that x term. We need an x squared because that makes it quadratic. But we need that bx term to be missing. Normally when it's missing, what do we usually have? If I would give you like 4x squared minus 25. Those are perfect squares. That's the ones we've seen so far. Okay, so let's go ahead and look at this one. Is that one that we've done before? Yeah. But let's try it using the new method, okay? Let's kind of talk through how this works, and then we'll kind of put it in steps for you. Oh, sorry. Isolate the, isolate the x squared. Sorry, I totally bypassed that part of the directions. To solve by finding square roots, isolate the x squared. Make a little note there. Or parentheses squared. We're going to look at 2 different styles of them today. And then take the square root of both sides of the equation. Okay? So number 1, x squared minus 25 equals 0. So normally with factoring, it was like we want it to be equal to 0 and then we factored, right? But let's now focus this one on the new method, which means you want to isolate the x squared or get it by itself. So I need to add the 25 over there. So x squared equals 25. Once the squared part is by itself, then we can take the square root. Because what's a square root going to do to a square? They're going to cancel out. Yeah, that's how you undo. But if I do it to one side of the equation, I got to do it to the other side. So x equals 5. How many answers should this problem have? It should have 2. Why do we only have 1? Let's look at this. They're not both 5. Let's look at it by factoring, because this is one that does factor, right? X squared minus 25 equals 0. Factoring, we'd set it equal to 0, and then we'd factor. How does that one factor? How does that factor? That's a difference of squares. So then you would set each one equal to 0 to solve. So you would tell me that x equals negative 5 and 5. Right, I got the 5. Which one was I missing? The negative 5. Is that always going to happen? So anytime you take the square root of something, plus minus is attached to that. You always have to add that. So make yourself a note, because that is the most commonly missed thing on all of these. If you take the square root of something, its answer is plus minus. If you take the square root, the answer is plus minus. Okay, so whatever you're taking the square root of, the plus minus attaches to that. Okay, that doesn't mean you do the entire problem and at the very end you throw a plus minus on it. That is not what that means. Whatever you're taking the square root of, that answer, plus minus. Whether you got other stuff to do afterwards or not, plus minus comes with that. Okay? So let's come back to this. So on your salmon colored paper, you need to isolate the x squared or parentheses squared, and you'll see what that means in a little bit. So that's the first thing, is you want to get that part, the squared part, by itself. Take the square root of both sides. And your answer has a plus minus on it. Now, important to recognize, though, we should probably add on here, in order to do the square root method, what must be missing? The bx. So make yourself a note, maybe even right up at the top. Must be missing the bx term. If it has a bx, you can't use this method. It doesn't work. Normally, like when we were doing factoring, everything was in ax squared plus bx plus c equals 0, right? Your three terms. It's the middle term. It's gone. Something that has just an x with it. Obviously, everything's going to have an x squared, because otherwise we don't have anything to solve if there's no x squared. But yeah, does that make sense? Okay, Izzy? Mm-hmm. Yes, quadratic formula does have the plus minus built into the formula. Mm-hmm. I will teach you this year when we do the section on quadratic formula. I will show you where that formula comes from. That might answer that question, like why is it there? I'll show you where it comes from. Quadratic formula is actually the shortcut, if you will, to completing the square. That's where it comes from. And we'll do that in class. We literally will take this equation, which is the general equation that we're working with. We will complete the square on this, and it turns into the quadratic formula. So then instead of completing the square on every single problem, you can just plug the numbers in the quadratic formula and be done. Okay, but yeah, I will show you where all that comes from. Donnie? Yes. Nope, they will be missing the bx. Because we're going to practice like each of these methods, and then eventually I'll give you a whole bunch of stuff, and then you decide. But we're not ready for that yet. Okay. So number 2. X squared minus 12 equals 0. Is it missing the bx? Is it missing the bx? Yes, it's missing the bx term, so we're okay. So we need to isolate the x squared. So we have to add the 12 to the other side. Once the squared part is by itself, then what? Take the square root. So we x equals square root of 12? Yes, factor tree. Yes. Yeah, that's not perfect, so we'll do our factor trees, which is why I had you practicing these last night so you remember how to do them. Good. It is 2 radical 3, but we know every answer should have a plus and minus in front of it, right? If you take the square root, that thing that you just took the square root of, the plus and minus is attached to it.
So anytime we do the square root method, we use plus and minus?
Yes. But again, I want to stress, the plus and minus is attached to what you put that on. Because there's going to be problems that are going to come in the future that there's more to do afterwards. Now these don't, but you'll see those in a little bit though, that I need you to know where that plus minus is attached to. Okay, it's whatever you took the square root of. Yes. Yes, they're in the grade book. Later. All right, number 3. What should we do with that one first? Ah, smart girl. She added the x over. Is that okay to do that? And then subtract the 6? Yeah, we can do that. So if I subtract the 6 and then add the x squared, makes it positive, which makes things a little easier. So 33 minus 6. Does that freak anybody else out because the x squared's on the other side? Some people like they go into like conniption and start shaking, right? Don't know what to do with it. Yeah, if this bothers you, is it okay if I write x squared equals 27? It's still this equals this. It doesn't matter which way you write it. It's totally fine. You can do that.
I subtracted 33 to 6.
Mm-hmm. You have to divide by -1. Yep. All right, if you guys didn't hear what Luke just said, he subtracted the 33 over here. Then that negative was still there, so then he had to divide by -1 to get rid of that. But yeah, you have to get rid of that negative. So either way. And then once the squared term's by itself, we take the square root. Square root of 27. Good. It's going to give us 3 radical 3. That's it? There's 3 radical 3? Plus or minus. Whatever you took the square root of, the plus minus attaches to. Are you seeing why I like this method? It should be pretty quick, pretty fast. Oh, but then I just added more numbers to it. You knew that was coming, right? All right, so number 4. Step 1 is to isolate the x squared. So what do I move first? Subtract 9. Girls, Tara. All right, subtract the 9. Take the square root right now? No, and I have a lot of students who try here, but is the x squared by itself? No. So we have to divide by 2 to get rid of that part. So x squared equals 2. Sure I can. Look, I just did. Look, I did. So we get x equals, and I think what she meant to say was I can't do a factor tree to simplify, right? It's just plus or minus radical 2. That's fine. Like, oh yeah, don't do that. Yeah, 1 times 1 is 1. But yeah, so if you get a point where the number doesn't simplify, that's fine. It just stays under the radical and the plus minus is attached to it. Mm-hmm. This step right here, I'm going to say yes, because I know what's coming in the future, and I think if we get in the habit of not writing it, it'll cause you issues down the road. Okay. And if you look at my papers, I still write all that every single time. Tara, did you have a question?
I was going to ask a question.
Okay. All right, so let's look at number 5 then. Tara's ready to go, right? So what do we move first? You could. You want to move the 9 and then move the 5? Yeah, you can do that. Mm-hmm. Sure. So she wants to add 9, and you want to add the 5x squared to the other side? Yeah, you can do that. So we'd have 12 equals 5x squared. Yep. And for those of you that really bothers, 5x bothers. If that bothers you, you can rewrite it that way. Sound like an old grandpa without his teeth in. All right, and then divide by 5. Wait a minute, I can't divide by 5. I mean, I just did, right? I just did. Yeah, so x squared equals, guys, fractions are a part of life. Fractions are okay. Everybody panics when they see a fraction. It doesn't divide, I did something wrong. No, you're fine. So my x squared's by itself. What's my next step? radical. But if I take the square root of a fraction, that's top and bottom, right? No reason to write a big tall one to only write in the next step them split. I'll just write one on top and bottom. Because I'm going to tell you right now, the students who write just one giant radical over the whole thing, they don't ever take this time then to write them split. And then they lose the radical on the bottom. So when you're doing fractions, one top, one bottom. All right, let's simplify. Square root of 12. 6 and 2. 3 and 2. Good. 2 radical 3 over radical 5, right? Because I can't do anything. And then I'll need to rationalize. Yeah. So I have to multiply top and bottom by radical 5. 2 radical 15 over 5. And then what else attaches to that? Plus or minus. You got it. So guys, all of these skills from the last chapter, you're going to see them kind of bleed into this chapter as well. Yeah, and then this chapter will bleed into the next chapter. We can't stop the bleeding in math class. All right, questions on anything we've done so far? I'm sorry. I'm sorry, I tried to make them pretty. I'm sorry. All right. You guys want to try number 6 on your own? Yeah, try number 6, guys. All right, so number 6, what do we do first? Subtract the 7. So 3x squared equals 23 minus 7? 16, good. Then what? Divide by 3. Does that divide? 16 over 3. I do a factor. I don't do a factor tree unless I actually have a radicals first. So x equals, we get plus or minus, right? That'd give me 4. Radical 3 on the bottom. I have to rationalize. So x equals plus or minus 4 radical 3 over 3. How'd we do? Did we do okay? Are we understanding the process thus far? Good. Sorry. No, if I ever go too fast, just tell me. Today's your day. Just to comprehend a little more. That's why we get practice. We'll work on it. So that's your get out of jail free card, right? All right, guys. Number 7. What should we do first? Subtract 19. Yeah, we got to get this part by itself, so we got to move stuff. So 3x squared equals negative 16. Uh-oh, can I have negative numbers? Yeah, I sure can. It happens. People panic when they see that stuff. That's right, they're on the number line. Divide by 3. Does that divide? No. So negative 16 over 3. It's not the same. It changes it a lot. So when I take the square root, again, fractions, top and bottom separate, we're going to have x equals, what's the top become? It does not become negative 4. There's an I in the square root of 16. So that's 4i over radical 3. Plus or minus, thank you. Good words. No, I just needed to move that. Then we multiply top and bottom by radical 3. plus or minus 4i radical 3 over 3. Now, kind of piggybacking on something Izzy said back there, she was like, yeah, there's a negative, it's on the number line, it's fine, it's a real number, all that good stuff. Are both of these numbers on the number line? On a number line, would either of those be on the number line? One of them would be. Which one? This would be on the number line. This is a number, you guys. I want to make sure we're clear on that, right? 4 times the square root of 3 divided by 3 is 2.3 blah, 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 blah. That's a number, right? This is a real number on the number line. It's not pretty, but it's on there. Is this? There's an I. It's imaginary. It's not one of your real numbers. This would not show up on a number line. Okay? Just so we're clear. All right. What about number 8? Yeah, let's add the 2. So 4x squared equals negative 15. Christian, or Christian, Adrian? Sorry, Christian. Are you with me? Your last names are close, so it always throws me. Yeah, Griffin and Griffith. Yeah, they're close. So in my mind, when I saw him, like the Griff part came to mind, I said Christian instead of Adrian. All right, good. You were just talking about it. Okay, so we're at 4x squared equals negative 15. Then what? Divide by 4. So x squared, does that divide? Negative 15 over 4. Then what? Take the square root, top, bottom. Don't jump the gun on those steps, okay? You don't say it. So x equals, good, I radical 15. Can I do a factor tree on the 15? I get 3 and 5, no pairs. Square root of 4? Do I have to rationalize? No. Good, done? Plus or minus. Now, I want to make sure you guys are clear on what plus or minus means. That means I have one positive answer and I have one negative answer. Okay? Yeah, and some students are like, can I just rewrite like one positive comma and then the other one negative? I mean, you can. I'm lazy. I'm not going to write all that. Right? There's no need in that. All right, why don't you guys tackle number 9? All right, guys. First thing, subtract the 27. So x squared equals negative 24. Then I have to take square roots. What happens when you take the square root of a negative number? We're going to have an I. So the I is going to come out. Don't lose track of that. Factor tree. So as far as you got. So we got a pair of 2's. So 2i. Singles go back in as a 6. And then don't forget your plus and minus. So plus or minus 2i radical 6. Okay, so the last part, some of you started to work ahead, and those of you that I saw working ahead, yeah, no, it wasn't so pretty. So let's talk about how this actually works. All right, so in the beginning, when I had your step-by-step, I said to isolate the x squared or parentheses squared, which is where this is coming from. All right, so we're going to isolate the parentheses squared and then do it like we did all the rest of them. So on this first one, my parentheses is already isolated. We would take the square root of both sides. What's the square root of x minus 3 squared? It's x minus 3. Right? We already talked about the radical, the square root, and the square. They cancel each other out. Square root of 49? Square root of 49?
7 times 7 is 49.
Right, but it's not just 7.
Plus or minus.
It's plus or minus 7. What did we talk about? Where does the plus minus attach itself to? To what you took the square root of. So that plus minus is attached to the 7. Okay? So when I add this 3, I'm going to write this a little bit differently just so we don't confuse ourselves. So that negative 3 becomes a positive 3 over here, right? Plus or minus 7. What's 3 plus 7? What's 3 minus 7? Negative 4. There's my two answers. The habits, or what people try to do, is they add this over and they're like, oh, yeah, it's plus or minus 10. No, it's not. Okay? Because if I would plug in a negative 10 up here, negative 10 minus 3 is negative 13. Negative 13 squared, is it 49? No, it's not. But if I plug in a 10, 10 minus 3, 7, 7 squared, 49. Plug in a negative 4. Negative 4 minus 3, it's negative 7 squared, it's 49. Okay? So when we're doing this, that's why I was trying to stress to you that plus minus attaches to what you took the square root of, not the final answer at the end. Okay? So on this one, what do you have to do first? Yep, divide everything by 2 first. Now, I don't actually divide into the parentheses because that exponent of the 2, the squared, is like holding all of that captive, okay? So I can just divide it out here. And I get y minus, not 2, y minus 1 squared equals 25. Can I ever distribute into a parenthesis that has an exponent on it? No one said it, but I just want to make sure we're clear. Could I have distributed this inside here? No, because it's got that exponent holding it all captive, so I can't do that. All right, so now my parentheses part is by itself, so we'll take the square root. So y minus 1 equals plus or minus 5. Again, I'm taking the square root of 25, which is 5. The plus minus attaches to that answer. So now I'll get y by itself. So y equals 1 plus or minus 5. And yes, you will always see me do that step right there so we can see it. So then what's 1 plus 5? 1 minus 5. And I'm done. Now, are all my answers nice, pretty, and perfect like that? No, they're not. So we need to take that into consideration as well, because a lot of times my answers still have radicals attached to them. So that's the kind of stuff we're going to see here. All right, so number 12, what do we do first? Divide by 3. So again, we're trying to isolate that squared part. X plus 2 squared equals 10. All I did was whisper your name. All right, so then we would take the square root. So x plus 2, square root of 10? Can I do a factor tree? No pairs. All right, so it's just going to say plus or minus radical 10. Right? The plus or minus attaches to what you took the square root of. So when I move this, notice I'm always moving it in front of that plus or minus, right? Because it's not attached to the radical. So that would become x equals negative 2, right? Moves over, becomes a negative, plus or minus radical 10. Can I do anything else with that? I'm done. Okay, they're not like terms, right? On the previous problem, these were like terms. They were just numbers. I could put those together. Here, one's a radical, one's not. They're not like terms. I can't actually add them together and get anything. So my answer would stop there, which I kind of like those even better, right? It's even less work that you have to do. Christian? That would be wrong. Yep. So his question is if I wrote it as plus or minus 2 radical 10, if you put it here, that's wrong. Because this is saying 2 is being multiplied by radical 10. This is saying the 2 is being added or subtracted with the negative 10. Definitely a big difference. Good question. What about 13? You can multiply by 3 or divide by 1/3. People panic again because of that fraction. Here, if it was a 3, you just divided by 3, right? So technically, could I divide by 1/3? Yeah, and dividing by 1/3 is the same thing as multiplying by 3. So whatever math skills you have in your background, whatever's comfortable for you guys. Either way, I get x plus 5 squared equals 21. Then what? Square root. So x plus 5 square root of 21. Good. Plus or minus radical 21. Because again, that plus or minus attaches to what I took the square root to. And then to get x by itself, subtract the 5 over. So negative 5 plus or minus radical 21. And I can't do anything with that. They're not like terms. I think those are my favorite because it's less work on my part. I don't actually have to tell you what the final answers are. All right, 14. Good. Subtract the 13. X minus 3 squared equals negative 9. All right, once your parentheses squared is by itself, yep, we'll take the square root of both sides. So x minus 3 equals just 3i? Good. Plus or minus 3i. That negative comes out as the I. Square root of 9 is just 3. Plus minus attaches to what you took the square root of. And then we move this to the other side. 3 plus or minus 3i. Can I combine those? Yes or no? No. They're not like terms. It's just left like that. How are we feeling? We all right? Nobody's going to panic on me as soon as I give you your assignment?